These are the answers to the worksheet you had for homework. The atomic number is 17. Atomic number gives you the number of protons. So the number of protons are also 17. Since it has no charge, number of protons equals the number of electrons. So that is also 17. Since the number of neutrons are provided, you do not look at the atomic mass off the periodic table. To find the mass number, you're going to add the number of neutrons plus the number of protons, and you will get 36. 17 will tell you what element this is. This element is chlorine. It has a mass number of 36 and an atomic number of 17. Remember, the standard format is we have the symbol. On top, this is the mass number. On the bottom, it is the atomic number. Neutral atom, because the charge is 0, and it's an isotope. If I compare it to the periodic table, the mass numbers are not the same. Number 2, the number of electrons are given. Since nothing else is given, it must be a neutral atom. So therefore, the charge is equal to 0. And the number of protons must equal the number of electrons. Since the protons are 71, the atomic number is also 71. If I look this up, this is Lu on the periodic table. It has a mass number given as 180, atomic number of 71. Again, this is a neutral atom. That is also an isotope because this mass number does not match the periodic table, or the other way is stated, the number of neutrons are not the same. Number 3, the number of protons are given, so we know that the atomic number is also 40. Protons and electrons are not the same. This is not a neutral atom. It has 2 more protons than electrons. We know protons are positive in charge. We know the electrons are negative in charge. So this should be a +2 charge. It has 2 extra protons than electrons. Since the number of neutrons are provided, we do not use the periodic table. To find the mass number, we add the number of neutrons, which is 46, plus the number of protons, which is 40. So this is 86. If I look up this element on the periodic table, it's zirconium. Zr, it has a charge of +2, a mass number of 86, atomic number of 40. This is an ion. Why? It has a charge. And if I look it up, the mass numbers do not match, or the number of neutrons don't match the periodic table, so this is also isotope. Number 4, atomic number is 92. That gives us the number of protons, which is also 92. Since the mass number is given, we do not use the atomic mass on the periodic table. To find the number of neutrons, it's going to be the mass number, 238, minus the number of protons, which is 92, and this is equal to 146. This is a charged atom because the number of protons and the number of electrons do not match. Since I have more protons than electrons, this is a cation, a +6, 92 minus 86. So if I look this up, this is uranium, 6+, mass number 238, atomic number 92. This is an ion because it's a charged atom. So the atomic number is 82. Atomic number also represents the number of protons, so this is also 82. This one has a charge of +4. So that means this is a cation. So I'm going to have 4 more protons than I have electrons. So there's going to be 78 electrons. So 82 minus 4. Since the mass number or the neutrons are not given, we use the atomic mass off the periodic table and round it to the ones place. The mass number is given, it is 206. And so to find the number of neutron, we don't use the periodic table. It is a given mass number minus the number of protons. This equals to 124. Number 6, the number of protons are given, 34. That means the atomic number is also 34. This has a -2 charge, so this is an anion. So that tells us we have 2 more electrons than protons. So 34 plus 2 is 36 electrons. The mass number, we do not use the periodic table because the number of neutrons are provided. So we take the number of neutrons plus the number of protons, and that equals to 79. 34 on the periodic table is Sc, selenium. It has a charge of 2 minus, which was given, atomic number of 34, and a mass number of 79. If you notice, this is an ion because it's a charged atom. And if I compare it to the periodic table, it is the same mass number, so it's just an ion. The number of protons is 48. That tells you that the atomic number is also 48. Since the number of protons and electrons are not equal to each other, this is an ion or a charged atom. Since there is more electrons than protons, this is a negative ion or an anion of a charge of -1. 49 minus 48 is 1. The number of neutrons, you will use the mass number minus the atomic number. We do not use the periodic table because the mass number is given. So this is 113 minus 48, which equals 65. 48 on the periodic table is cadmium, Cd. It has a charge of -1. Its mass number is 113. Its atomic number is 48. This is an ion. That is an isotope because the mass numbers do not match. In number 8, the atomic number is given, which is the same thing as the number of protons. Since it has no charge, the number of electrons are also equal to the protons. Since the mass number is given, we use the mass number given to find the number of neutrons, which is 42 minus 21, which equals to 21. 21 on the periodic table is scandium or Sc. Its mass number is 42. Its atomic number is 21. This is a neutral atom because no charge is given, and it is also an isotope because the mass numbers do not match. 31, 15, this is phosphorus. The atomic number is the bottom number, so that is going to be 15, which gives us the number of protons. Our mass number is on top, which is 31. The charge of phosphorus is 3 minus, so this is an anion. This tells you the number of protons and electrons will not equal. There will be more electrons than protons. So to find the number of electrons, it's 15, the number of protons, plus 3, because electrons were gained, so you need to add them. So this one has 8 electrons. Since the mass number is given, it is the mass number minus the number of protons will give you the number of neutrons, which is 16. Phosphorus is an ion because a charge was given, and the mass number matches the periodic table. 83 gives you the number of protons, which is the same thing as the atomic number. Since the number of protons and electrons are not the same, this is an ion. There are 3 more protons than electrons, so this is going to be a cation of a charge of +3, 83 minus 80. Since the number of neutrons are given, we do not look up the mass number on the periodic table. The mass number will be the number of neutron, which is 126 plus 83, which will give us 209. This is bismuth on the periodic table. charge of 3 plus, mass number of 209, atomic number of 83. This is an ion because its charge is 3 plus. So next one is silver. It has an atomic number of 47 given to you, or you could look it up because you know the element. This gives the number of protons, which is also 47. Since no charge is given, the protons and the electrons are the same. The charge is 0. The mass number is given as 108 in the problem here. So the number of neutrons is the mass number minus the number of protons, and this will give you 61. This is a neutral atom, and it matches the periodic table, so it's just a neutral atom. Next one is 49 number for the proton, which gives you the atomic number. Since its charge is plus 3, it's going to have 3 more protons than electrons. So it's going to have 46 electrons. 49 minus 3 because it lost. Since the mass number is given, the neutrons is 116 minus 49, which is 67. This is indium on the periodic table. It has a plus 3 charge, a mass number of 116, and an atomic number of 49. This is an ion because it's charged. It is an isotope because the mass numbers do not match. 13 has 53 protons, so that means the atomic number is 53. Its charge is a -1, so this is an anion, which means it has 1 more electron than proton, so this is going to be 54. The number of neutrons is 128 minus 53, which is the number of protons, and this is equal to 75 neutrons. If you look this up, this is iodine, which has a charge of -1, mass number of 128, and an atomic number of 53. This is an ion because it's charged. It's an isotope because it does not match the periodic table. 76 gives you the number of protons. Atomic number is always the number of protons. The number of protons and electrons are not equal to each other. This is a charged atom. 76 minus 72 is 4. It is a positive charge because there are more protons than there are electrons. Since the mass number is provided, to find the neutrons, we add 188 minus 76, which will give you 112. This is osmium, charge at 4 plus, so it's an ion, mass number of 188, atomic number of 76. This is an isotope because the mass number does not match the periodic table. 14 is the atomic number, so that is the number of protons. It has a charge of 4 plus, so that means it lost 4 electrons, so 14 minus 4 will give you 10 electrons here. Since the number of neutrons are given, we do not look up the atomic mass on the periodic table. Mass number is protons plus the neutrons, so this is going to be 30. This is silicon, charge of 4 plus, 30 over 14. It is an ion, and the mass numbers don't match, so it's an isotope. For number 2, the mass number and the number of neutrons are given, so you could find the number of protons because mass number is equal to the protons plus the neutrons. So 75 minus 42 is 33. Since the protons are 33, electrons are 36, this is a charged atom. It's 36 minus 33 because there's more electrons than there are protons. Since the number of protons are 33, the atomic number is 33, which is arsenic. As is a charge of 3 minus, mass number 75, atomic number, and it's not an isotope because it matches the periodic table mass number. Number 3 has 51 protons, which is the same as atomic number 51. The number of electrons are 54, so it does not match the protons. So this is a charged atom. It has more electrons, so 54 minus 51 is 3. This is a 3 minus again. Since the number of neutrons are given, we don't use the mass number on the periodic table. The mass number is going to be the number of protons, which is 51, plus the number of neutrons, which is 79. So this is equal to 130. This is antimony, Sb 3 minus, which has a mass number of 130, atomic number of 51. This is an ion, as well as an isotope, because it does not match the mass number. Number 4, atomic number is 99. Number of protons are also 99. Since the protons and electrons do not match, this is an ion. This is a +3 ion, a cation. 93 minus 96 is 3. There are 3 more protons, meaning there are more positive charges than negative charges. Since the mass number is given, we do not look it up on the periodic table. To find the number of neutrons is 252 minus the protons, which is 99. So this is equal to 153. This is Einsteinium, Es, 3 plus mass number of 252, atomic number of 99. This is an ion, and the mass number matches the periodic table, so this is not an isotope. Number 5, we have lead. Lead has an atomic number of 82. It also has 82 protons, because atomic number is equals to the number of protons. It has a mass number given as 208. The number of electrons are not the same as the protons, because it has a charge of +2. This is a cation, so it's going to have 2 extra protons than electrons, so 82 minus 2 will give you 80. Since the mass number is given, we find the number of neutrons by taking the mass number minus the atomic number, which gives you 126. This is an ion. It is not an isotope because it matches the periodic table. Number 6, 52 is given as the number of protons, so my atomic number is also 52. The number of electrons, there is going to be greater, so it's going to be 54 by 2, because the charge is -2. That means it has 2 extra electrons. Since the number of neutrons are given, we take the number of protons, which is 52, plus 76, which is the number of neutrons, and that will give us 128. This element is beryllium, Te, charge of 2 minus. It has a mass number of 128, atomic number of 52. This is an ion. It is not an isotope because it matches the mass number on the periodic table. Number 7 has 48 protons, so my atomic number is 48. My protons and electrons are not the same by 1, so this is going to be a -1, an anion, because there's 1 more electron than proton. The number of neutrons, we take the mass number given, not the periodic table, 113 minus 48, and you get 65. This element is cadmium, Cd, charge of -1. It has 113 mass number, atomic number of 48. This is an ion. That is an isotope because the mass numbers don't match. Since it has a +6 charge, it has 6 extra protons and electrons. 42 minus 6 is 36. Since the mass number is given, to find a neutron, we use the given mass number minus the number of protons to get 56. This is mobilium, Mo, with a charge of 6 plus, mass number of 98, atomic number of 42. This is an ion and an isotope. Number 9 is nitrogen. the atomic number is 7. Therefore, the number of proton is also 7 because it's given as 7. We know the charge is 3 minus right here. So that means it has 3 extra electrons because this is an anion. So 3 plus 7 will give you 10 electrons. The mass number given was 17, so that's the given mass number. So the number of neutrons is going to be the mass number 17 minus the proton, which is 7, so which will be 10 neutrons. This is an ion because it's charged, and it's also an isotope. Next one is 83, is the proton, which is the atomic number. We have a charge of plus 5, so there is 5 more protons than electrons. So 83 minus 5 is 78 electrons. Since the mass number is given, we use 209 that's given minus 83. This is 126. This is bismuth, Bi, charge of 5 plus 209 for the mass number, atomic number of 83. This is an ion. Next one is palladium, Pd. Atomic number is 46 given right here, or you could look it up on the periodic table. It's also the protons. Since no charge is given, this is a neutral charge, so the electrons are exactly the same. My mass number is the number on top, that's 110. So we use that to find the neutrons. We do not use the periodic table, so it's 110 minus the number of proton, which is 46. So this should be 64. Number 12, 50 protons are given, so that is my atomic number. The charge is 4 plus. That means this is a cation. It has 4 more positive charge, so this is 46 electrons. The number of neutrons is going to be the mass number minus the number of protons, which is 50. So this is equal to 74. 50 on the periodic table is 10. It is a charge of 4 plus, a mass number of 124, an atomic number of 50. This is an ion. It is also an isotope because it does not match on the periodic table. 35 will give you the atomic number because the atomic number and protons are the same. The charge is -1, an anion, so it's going to have 1 more electron because electrons are negative. Since the mass number is given, 79 minus 35, which will give you 44. This is bromine, which has a charge of -1, a mass number of 79, an atomic number of 35. This is an ion. That is an isotope. 60 is an atomic number. It is the number of proton. The number of protons do not equal the number of electrons by 2. 60 minus 58 is 2. We have more protons, so this is going to be a positive or a cation. Since the mass number is given, to find a neutron, we use the mass number given. 148 minus 60 will give you 88. This is Nd. The charge is 2 plus. Mass number is 148. Atomic number is 60. This is an ion. It is also an isotope because it does not match the periodic table. This is a review. Atomic mass is a decimal number. It is a decimal number because it's the average of all the naturally occurring isotopes. The units are atomic mass units, AMU, or grams. 1 AMU is approximately 1.66 times 10 to the negative 24 grams. The general formula to solve for atomic mass is we take the sum of the percent abundance times the atomic mass over 100. If you choose to already convert the percent into decimals, then we do not have to divide by 100. So you could either use the top equation or the bottom equation. So calculate the atomic mass of gold. 50%, that is gold 197, 50%, that is gold 198. So the first thing you want to do is write the equation. the percent abundance of isotope 1 times the mass of isotope 1 plus the percent abundance of isotope 2 times the mass of isotope 2 divided by 100. So after writing the equation, we plug the numbers in. The first one is 50%, so 50% atomic mass is 197, so 197 plus 50%, 198 divided by 100. So if you multiply 50 times 197, then you multiply 50 times 198, then you add, you divide by 100, and you get exactly 197.5. If units are not given, you can use AMU or you can use grams. We do not do sig figs for atomic mass units. Pause the video and try this problem on your own, and then check your answer. Pause the video, solve the problem, and check your answer. We're calculating the average atomic mass for magnesium. There are 3 isotopes, so if I have to write the formula, average atomic mass is equal to percent abundance of isotope 1 times the mass of isotope 1 plus percent abundance of isotope 2 times the mass of isotope 2 plus percent abundance of isotope 3 times the mass of isotope 3 divide by 100. If you're multiplying by percent, if you already converted it into decimal, then you do not have to. So in this problem, it is already made into decimals, so we do not have to divide by 100. So this is going to be 0.7870. This is the percent abundance of 1 in decimal format times the atomic mass, 23.985 AMU of isotope 1, plus the abundance of the second isotope, which is 0.1013, times the atomic mass of isotope 2, which is 24.986, plus the abundance of isotope 3, which is 0.1117, times the atomic mass, which is 25.983 AMU. So you do all the parentheses work first. You need to multiply these two numbers, then multiply these two numbers, then multiply these two numbers, then add them. We do not do sig figs, just keep all the digits. So it's around 24.31. Since units of AMU are given, my final units will be AMU. Pause the video, solve the problem, and then check your answer. We are finding the atomic mass of hafnium, HF. It tells you that out of every 100 atoms, 5 has a mass of 176. Since 5 has 176, it tells you that 5% of the atom has a mass of 176. 19 has 177, so that's 19% has 177. 27% has 178. 14% has 179. And 35% has 180. So since it's out of 100 and the total adds up to 100, we can make it all percent. Or we could automatically convert them into decimal. Equals to the sum of the percent abundance of each of the isotopes times its mass of its isotope divide by 100. Since this one has 1, 2, 3, 4, 5, you should have 5 of them. So if I plug this in, this is going to be 5% times 176 plus 19% times 177 plus 27% times 178 plus 14% times 179 plus 35% times 180. Divide by 100. In this case, you have to divide by 100 because everything was in percent. You need to do the parentheses work first, so you need to multiply these two, these two, these two, these two, and these two, and then add all the numerator and then divide by 100, and you should get approximately 178.55. Since no units are given, you could use AMU or grams. Pause the video, solve the problem, and then check your answer. What is the atomic mass of an element with 3 isotopes with the following information? So scandium has an atomic mass of 44.97 AMU. It has 3 isotopes. So my formula is going to be average atomic mass is going to equal to percent abundance of 1 times the mass of isotope 1 plus percent abundance of 2 times the mass of 2 plus percent abundance of 3 times mass of 3 divide by 100. So now I'm going to plug in. For isotope 1, that's the mass, 42, and abundance is 75. So this is going to be 75% times 42 AMU. For isotope 2, it's going to be 10% times 44 AMU. And for the third isotope, we don't know the abundance, so we are looking for that percent times 45 AMU. Divide by 100, and this has to equal to the atomic mass of 44.96 AMU because that is the mass given. So for most of you, I would simplify by moving the 100 to the opposite side by multiplying both sides by 100. So if you multiply both sides by 100, that cancels out that with the 100 on top. And then 100 times 44.96 is 4,496. This is going to equal to 75 times 42, 10 times 44, and percent times 45. So 75 times 42 is 3150. 10 times 44 is 440 plus 45%. And we are looking for this percent here. So the next thing you're going to do is you're going to simplify. We're going to add these two. When I add those two, this is 3590 plus 45% equals to 4,496. We're going to isolate the 45%, so we're going to subtract both sides by 3590 minus 3590. So this becomes 45% equals to 906. So now I'm going to divide both sides by 45 to get the percent. So if you do your math correctly, you should get around 20.1, repeating 333% as your abundance.